All right, welcome back to our video series on analyzing the coronavirus data. So in this video, we're going to go ahead and pick up where we left off last time, which recall we have a working model, which remember a model is just another word for an equation. So we have a working equation, and so now let's see if we can make some predictions using that equation. And then maybe we can compare those with real data. So let's go ahead and dive into our program here. So when we open our program, we get a visualization, but as we can see right now, this isn't really fitting this part of our data here at the end. So recall, in order to fix that, we adjusted the start at variable. In order to fix that, we adjust start at. So we'll have this start at day 30. And so now we get a model we expect. So remember that start at variable is saying how far into the data we're actually going to start using for our model. Okay, so remember, if our first day is January 22nd, 30 days in is around, or is, I guess, February 21st. So it's this right here where we first hit 15, and then it's 15 again, 15, then it's 51, 51, 57, 58, and so on. Okay, so that's what we're seeing right here. These red dots, and we have our blue dots. Okay, now if we were to plot, so right now we have plot 60. So remember, we're starting at 30 and we're plotting 60 days out. I think what we want to do is we want to plot our actual data, right? And then on the same graph, plot our predicted data. Okay, here's what we're going to do. We're going to say if num days is none, then num days equals len of self.dates. If num days is greater than the len of self.dates, then I think we need another variable here because, okay, so let me talk out loud. I'm thinking it. So right now we have, we're getting our y value from our data, and we need it to start at here and stop. All right, so we're going to start at our default start at, which is like 30. And we want to stop either at the number of days given or at the last data point. In other words, we can't plot actual data if we don't have the actual data. So what we're going to do is I need another variable, so I'm going to put end at. All right, so end at is going to just be num days. So if end at is none, then end at is going to equal the length of self.dates. If end at is past the end, or actually, you know what, I'm just going to say or end at is past the end, so len of self, end at is greater than len of self.dates, then end at equals len of self.dates. Right. So what this will allow us to do is end at is going to be where we actually end. So we can predict past the end of our list, num days, right? But then right here, we're going to tell this to start at, and we'll say end at. Okay. Let me clear this up here. Okay, now I'm going to add a comment here because, you know, it's been a week since we've worked on this, and I'm finding myself already kind of forgetting what different things do. So this is going to plot the actual data as points and the predicted data as a connected line. Num days is the number of see, it's getting you know, I'm feeling like this start at thing is going to be misleading, because I'm going to say I want to plot like, 30 days of data, but to do that I actually have to put in 60, right? So the number, so let's I'm going to get this working, and then we'll go back and let's try to fix that, because I don't like how that's going to work. Num days is the number of days of data to plot and or predict, right? If num days is greater than the number of actual data points, then the remainder will be predicted. So again, so I've got 70. I'm going to go ahead and say plot 75. Actually, I'm going to say plot 60. I just want to make sure I didn't break anything. So in other words, I want to make sure I get the exact same graph that we got last time. Cool. And so now if I put, say 70, I'm going to expect the same data points, but then I'm going to expect a line to go past the end. And I'm getting an error. What is this error? Okay. So on line 71 in plot.plot x pred list. And it's saying x and y must have the same first dimension. So see, the x on this is not matching up with the x on that. So I'm going to have to do another x. I'm going to have to say, we'll call this data y and data x. Or you know what? We'll say actual y and actual x. So actual y, actual x. All right, so that's what's going to get plotted here. Actual x, actual y, and then this will be predicted y and predicted x, which is going to be the same thing as this. I for I in range len of predicted y. So then here we'll change this to predicted y and predicted x. Now, oops. Notice how we're telling it to plot on the same, we're saying plot and then plot dot show. So again, that's what's causing them to show up on the same graph. Y is not defined. Yep, it's not. Actual y. When you change variable, you got to change them everywhere. There we go. Okay, so now we can see, this data is fitting, and then we can see, okay, this is going to continue on up along these lines. Okay. Now, just thinking about our data for a moment. Remember, here was our last data point is March 21st, right? So this was saying, and remember, we're going, how far past the end are we going? Roughly 10 days past the end, so that would be March 31st. So according to our model, sometime around March 31st, we would have expected somewhere in the neighborhood of 700,000 cases. And we know that didn't happen, right? So that's actually good, right? But that's something to keep in mind. Our model isn't exactly a super good fit with reality, which is okay. Okay, but so that's good. Thinking ahead or looking ahead, we can see, okay, our model isn't perfect, and we're going to figure out how we can make it better. So I want to end this video by let's get this. I don't like this putting in 60 to get 30 days of data, right? That's counterintuitive. That should kind of be hidden from whoever's calling this function, right? It should be showing me 30 days of data. It's unfortunate that our model doesn't fit when we do things like, start it at 0, right? But that's okay. What we can do is in our predict down here, or actually in our get model, it's saying start at 30 and it's generating the model. So what happens if we plot 30 here? I'm just curious. Should get an error or something, I think, or nothing. There we go, yeah. But if we look down here, we can see that, okay, the data's still there, okay. So when we plot 60, 60 is getting put in here for num days. We want to, if we put in 60, we actually want to, if we put in 30, we actually want 0. So I think inside of predict, that would be where we would actually want to do this change. Right, so I'm going to write here, I'm going to say for x in range, num days, and if I put in 30 for predict, I want I'm not remembering why I have num days minus start here. I think I'm actually just going to put num days right there. Now for this getting the data, we actually wanted to start at 30 and go to end at. So I think we want end at to be num days plus start at, or I'll say start at plus num days. All right, so then if end at is more than none, or if okay, yeah, I think that will do what I want. Right, which again, my goal would be, I want num days to be the actual number of days I'm going to predict. So I'm going to put, or plot, I'm going to put 30 in here. So I would expect 30 days to be plotted. Let's take a look. There we go. So we go from 0 to 30. If I put in 50, then I'm going to expect 50 days to be plotted. Right, okay, good. That's better. That works more like I would want it to. So yeah, I don't remember why we did it that way before. So, oh well. We do have it now visually predicting the number of cases in a window. Right, so we can look past our actual data. But let's think about a couple things that we do that I want to do here. So we may use this is actually graphically. That's what we just did. So that's a check. We probably, it would be nice to know like the actual number versus predicted number and like some kind of a difference. So actual versus predicted by date. Show the difference between actual and predicted. What else? Show the actual versus predicted by date. Show the difference between actual predicted. Maybe plot. You know what? Find the daily difference in the actual data. In other words, like, you know, how many more cases do we get on this day than the previous day? Maybe plot that trend. Plot the daily difference. Yeah, so those are some things we could definitely do. So thanks for watching this video, and we will continue next time.